Welcome back. This week's project is a gravity operated phone stand. So we made this stand that when you put your phone on the pedestal, it's going to rotate these arms to come in and grab the sides of the phone. We'll go through how it was designed and some of the considerations we had to work around, then how to set up your build plate and how to assemble it so you can make your own. Here's the phone stand, and we could take a look at the principles at work here and how we made this thing function. It's driven by gravity and the weight of your phone. So we're showing iPhone 15 Pro, I think, in a case here, which we designed this around. It also works on a Google Pixel, I think 7 in a case, but it has a long range for how far it can go to grab the sides of a phone. There are gears in here and a rack gear on the moving platform so that as you push down on the platform, you rotate the gears, and that's what moves the arms in. They're beveled on either side, and there's a female bevel on the inside of the rack gears, and that's what keeps the platform from falling out the front. So we pivot on these pins, which are round for the section that they're through the arm while they're in the hole. That section is round, and then we used a hexagon shape as the interference socket, and that was so that we could print the base on its side and just print these as overhangs. If we'd printed circles here, the tops get out of round and then they don't work as well. We had many iterations of this. One of the strange things is because these are 3D printed parts, they print quite hollow. And we originally didn't have this front lip. And if all the parts are solid, it says that the center of mass is back here and the thing shouldn't tip over. But when we printed it, because it is hollow, the actual distribution tipped the thing over forward every time you picked up your phone. And that was how we got this little ledge in the front for stability. We also had a single leg kickstand in the back so that there was a single pivot point here. And when you tried to use your phone, especially up in the top corners, you would rotate it over to the sides and it would tip over. So we found out that we needed a big rectangular footprint for stability too, or at least we need the corners. Then we need these arms to have a center of mass that is out here, away from the pivot, in the direction we want it to open, so that the weight will be enough to both fall this way and the two of them will overpower the weight of the center platform. So as gravity pulls down on both arms and they rotate away, they're going to drive the platform up like this. So they would keep going and they would fall all the way over like this if we weren't careful. So we built in these stops, and when this surface makes contact with this surface, that's as far as it opens. So we go to here, and these things will sit out nice and wide so that you can get your phone in there. And then on the way down, this will push until we make contact here, and then it will sit suspended because it can't move anymore. If the phone were narrower, it would go all the way down until it hit these diameters, and that would be the limit of travel in the down position. So if you're just playing with it on the desk, it's going to go from where it makes contact here to where it makes contact here, and that'll be its full stroke. So this is carved out if you want to put your charger in. That's kind of it. So all you really need to do is get these pins in the holes, get the teeth lined up, and gravity should do the rest. Here's the print bed setup. We want our parts in these orientations so that we can print without support. So we'll start with the center pedestal. The slot should face up, the rack teeth. We'll print like this. There's an overhang of 45 degrees on the inside here, so it'll be able to print that no problem. These guys are two-dimensional. They need to be on their side. It doesn't matter which side, but you want the teeth to be facing like this so that they'll be strong. The holes will be nice and round. And the stand is going to be printed on its side. This is all 45-degree overhang, so it will print that. Then we made the interference features hexagons, and the points need to face down, and then it can print right over those holes. Last thing is the pins. We're just going to put the head down. No overhangs on this one except the chamfers, but it'll just allow it to print in that orientation. And we're not asking for insane strength out of these guys, so the fact that this layer orientation isn't the strongest won't hurt us. So set them up like this, whatever you want to do for colors, and you should be good to go. Here are the parts we should have printed. We've got 6 parts, but there's only 4 unique parts. These are the same, so 2 versions of this, 2 pins, and then 1 of each of these. So first things first, we put a pin through an arm, and we make sure the arm faces in, and then line it up with this hex, and push it all the way down. And this should rotate. Then we take this guy and we're going to line up this last tooth with the last slot. And then we're going to push these flats together on the bottom. So we want to close this gap so that they touch. Then Kind of hold that still. Put this one in the same way. Last tooth in the last hole, and then get the flats to touch. So now you're going to line up the other hole through here. Get the hex aligned. You might have to turn this a bit. Push it down. And now you're done. So gravity should be pulling these arms to the outside when you let them go. And if you push down the middle, they should close up. So that's the test to make sure everything's right. And then you can throw your phone in it. And you're finished.